Hi, welcome to my Lab 1 report. The purpose of this experiment is going to be to use clear tape to understand the interactions between household items, find the charge of one piece of charged tape, and to use physics concepts to model electric force and gravitational force on one piece of charged tape. The assumptions we can make in this experiment are that each piece of the charged tape can be simplified to a singular point charge, and each piece of U-tape has the same net charge. The results that we've gotten from the experiment are the charge of tape is going to be 1.196 times 10 to the negative 8 coulombs, and the electric force acting on the tape by the other piece of tape is going to be 2.06 times 10 to the negative 3 newtons, and that the tape is positively charged. The main physics concepts we're going to be using are Coulomb's law, which can be used to find the electric force due to a point charge, gravitational force due to Earth, and Newton's second law, which we can use to model how the electric force and the gravitational force interact with each other. The main lab procedure is going to be to create U-tapes. So using two pieces of tape to create a charged one, and we can verify if it's charged by bringing our hand close to it. And if it attracts with our hand, we can verify that it is charged. We're going to do this twice to make two pieces of charged tape. And then we're going to suspend one, we'll call this tape B, between two neutral objects, and bring tape A closer to it and measure the distance when it floats. We can also test the interaction between the tape and a pen, which we will make negatively charged by running against clothes or hair, and observe that interaction as well. The key observations made are that the U-tape A and U-tape B are going to repel each other, and I have observed a separation distance of 0.025 when the tape B starts to float. The U-tape is also attracted to my hand as well as the negatively charged pen, and from this we can conclude that the U-tape is positively charged because it's attracted to a negatively charged object and repels the other U-tape. We've created this free body diagram, which we can use to model the system of U-tape B, which is suspended. We'll have in the positive y direction the electric force by U-tape A on B, and we'll have in the negative y direction the gravitational force due to Earth. Because this system is static, meaning the tape B is not moving, we can conclude that the gravitational force and the electric force are equal but opposite. To calculate the force and the charge of the tape, we'll use the tape area from the tape length and width and find the mass of the tape from the tape length to find the gravitational force on tape B. This can be done by multiplying the mass times the acceleration due to gravity. And as said before, the electric force is equal but opposite to gravitational force, meaning it's going to be positive 2.06 times 10 to the negative 3 newtons. We can use that electric force to calculate the charge on the tape by also using the separation distance, which we measured. And by rearranging the variables in Coulomb's law, we have calculated a charge of 1.196 times 10 to the negative 8 coulombs. And this value can also be used to calculate the number of electrons on tape B and the ratio of electrons to atoms. Here we have the Glowscript model that I've created by using the separation distance between the two pieces of tape, the mass, and we can see the two arrows representing the positive electric force and the negative gravitational force. And we can use our formulas in our model to calculate the charge of tape B as shown surrounded by the blue box, which is going to be 1.196 times 10 to the negative 8 coulombs, which is very similar to the one we calculated in our experiment. Further questions to consider are if electrons had positive charge and protons had negative charge, how would this change our observations? The observations are still going to remain the same. The two U-tapes would still repel each other, but they would now be negatively charged. Why is it important to handle the charged tapes as little as possible? This is to avoid any contact between our hands and the tape because this can cause a transfer of electrons. If we handle the tapes with our hands too much, they can pick up the electrons from our hands or other objects and make them more neutral and less charged, which could alter the results of our experiment. And moving to the discussion, we were able to successfully use Coulomb's law, Newton's second law, and gravitational force to calculate the charge on one U-tape. We were able to model a system where the electric force and gravitational force are equal but opposite. Some possible sources of error are going to be lack of precision in measuring the tape width, length, and separation distance. Using better tools to calculate these values are going to give us better, more accurate experimental results. And second, as discussed before, improper handling of the tape, which can cause transfer of electrons, which can affect the observed interactions as seen um, between the two tapes or the other objects, which can lead to inaccurate separation distance values.